In this wind farm example video, we'd like to show you the PQ diagram script that's included in this project. The script can be exported for use with other projects and comes with documentation that can be accessed via the Examples dialog. Study Case 4.1 should be activated. For wind turbines, as with other generators, capability curves are used to specify their reactive power capability. In this model, there are 6 identical wind turbines, and we can look on the load flow page of one of these to see its capability curve. We can see that in fact there's a set of curves because the capability is dependent on the terminal voltage of the unit. For a wind farm connection, it's essential that the capability of the wind farm as a whole meets the applicable standards at the point of connection. The script that's provided in this project can be used to generate PQ diagrams for the whole wind farm, and these PQ diagrams allow the user to compare the wind farm capability with the requirements of the selected standard. The diagrams are generated by carrying out active power sweeps, which can include positive and negative active power ranges. 2 sweeps are executed, one with a minimum reactive power and one with maximum reactive power. Let's look at the script and understand some of the settings. In the External Objects pane, this feeder element defines the wind farm. The requirement object is critical as it provides the requirements against which the wind farm should be assessed. The selected object can be a single requirements matrix or a folder that contains a set of matrices for different voltage levels. In this case, the requirements are specified for 5 different voltage levels, so 5 diagrams will be generated. Each matrix contains megavar capability requirements for certain active power outputs, together with the requirements for when the plant is not operating. This object is the external grid, whose voltage set point will be adjusted to the required voltage levels. This bus bar is referenced by the external grid as the reference bus bar for the voltage control. This is the station controller for the wind park generators. And this setting means that we have opted to enable the station controller in the analysis. This object is a switchable capacitor that's used to provide reactive power compensation. With this setting enabled, the script will set the capacitor to minimum step in the first sweep and maximum step in the second. During the sweep of active power, some elements might be overloaded, and it's possible to manage these overloads by limiting the reactive power output of the individual wind turbines. In this study case, we have not selected this option. Likewise, the reactive power output can be curtailed if necessary in order to keep voltages at the generator terminals within limits. This option has been selected. Let's now run the script and have a look at the diagrams that are generated. Starting with the diagram at 1.1 per unit voltage, this red curve shows the capability of the wind farm, and the blue curve the minimum requirements of the standard. We can see that the requirements are all met for this voltage level because the capability curve lies entirely outside the requirements curve. Similarly, for the other voltages, we can see that the power plant can deliver more reactive power than is required by the standard. In the output window, detailed output is provided for each case. Although the requirements of the standard have been met, it can be seen that this comes at the expense of some overloading of transformers and lines within the wind park network. In the next study case, therefore, we've selected the option to limit the reactive power output where required in order to avoid overloads. We'll run the script again. Looking first at the output window, we can see that there are now only 2 overload warnings, and the overloads are marginal. The information messages indicate how the reactive power is being limited. Let's now look at the PQ diagrams. At higher voltages, the outcomes are still fine. However, at lower voltages, the wind park fails to completely meet the requirements due to the limitation on the reactive power output. These assessments indicate that the design of the wind park components may need some change. The PQ script can be used to investigate the reactive power capability of a wide range of power plants modelled using static generators, synchronous machines, asynchronous machines, or PV systems.